Það segir ekki bara geima spjallið til eftir. Ég fann einn hérna á ganginum, þannig að við erum og Þórólfur komin líka, sko. Þá það hvað? Ég búinn að missa töluna yfir málstofarnar á árinu, það allavega önnur í vikunni. Ég ætla að reynda líka vekja athygli á því að í byrjun júní þá ætlar Helgi Tómasson að tala fasteignaskatta. Þarna fyrir áhugasaman. Þetta því að uppgjörið ykkar birtist náttúrulega núna næstu mánaðamót og Helgi hefur að skipa sér ákveðin sessi í umræðinu þennan tiltekna skattstopp. En í dag fengi ég þá gest frá Frakklandi, en hann nú sænskur. Henrik Andersson, hann ætlar að tala greiðsluvilja fyrir ferðamátum. Hann var tilbúinn að taka spurningar bara jafnt og þétt, þannig að þið hyggið þá getið að ýta við honum. And yeah, so we'll skip up English. Yeah, so we just welcome Henrik, and you're coming from France, but you're Swedish.
Yes.
Correct? Yeah.
Yes.
Yeah, I mean the floor is yours. Just go, please.
Thank you very much. Apparently, Scandinavian languages and Icelandic have the same roots, but not sure what was said about me. But I hope you said it. Happy to take questions during the talk. Makes it more interactive. So thank you very much for having me. So this presentation I'm going to do today is about traffic safety, and it's a joint work with Henrik Andersson, who's currently both in Sheffield and in Spain. He's moving to Spain. Health economist, and Jan Ekstad, who's a transport economist in Sweden at VTI. So as most of you know, and this is why I will go very quickly through these slides, that without any market failures, we don't need to intervene. We can let people decide themselves on all the decisions if we assume that they are the best judges of their own welfare. But in many cases, the environment or transport, there are a lot of market failures that motivate government interventions. So it could be simply that people are not informed of the consequences of different, let's say, health risks. And in this case, in this paper, we talk about safety, and safety is related to your own behavior, other people's behavior. There's a lot of externalities, for instance, on the roads. My exposure to risk and traffic environment doesn't only depend on my own behavior, but also other people's behavior. And so what I'm trying to say is that it is important to do what we're doing in this study, because there are the externalities. We need government intervention. But if we have government intervention, we also would like to evaluate those policies. Are they good for society overall? So reducing the transport risk is a benefit for society, because we don't want to face the risk of injury or death. So for our own benefit, but also for benefits about people around us. They also don't want us to die, hopefully. So there are a lot of benefits related to reducing risks, but also, of course, a lot of costs. So do benefits exceed the costs? That's a big question. So can we motivate the cost by having large benefits? Usually we do use a benefit cost analysis, or cost benefit analysis, as we usually call it in Europe. But for that, we need monetary values. So we need monetary values for not only, say, the safety effects, but also for all the other effects when we evaluate different transport policies. So clean air, reduced travel time, etc., etc. But regarding many of these benefits, there are no official monetary values. So we need to use some kind of technique in order to extract information about people's preference, because we are doing a welfare analysis. We want to know about people's preferences. And for that, we use no-market valuation techniques. And regarding transport projects, usually the two main benefits when transport projects are planned are reduced risk and reduced travel time. So it is important that we get those measures right in order for us to have well-informed decisions in the end when we use cost-benefit analysis. Should be that one, right? Yeah. So regarding non-market valuation, we broadly use, as I mentioned on the previous slide, two different approaches, either stated preference or revealed preference. And we use them for a lot of different type of goods. So not only transportation, but also health effects, environmental effects. So for all this type of goods and services that we're interested in, that don't have an easy available market prices, or do have market prices where we believe that we cannot trust those prices to really reflect society's benefits or costs related to those. So for instance, if we have price interventions, the price in the market don't reflect the true market value of the good or the service. So in all those cases, we need to use these non-market valuation approaches. So regarding the first one, SP, stated preference, so everything is hypothetical. So we construct a hypothetical scenario in order for us to elicit information about people's preferences. The two main approaches, which we are going to use in this presentation as well, the continued evaluation method, choice experiments. So I will come back later and show you an example of those approaches. I would not spend too much time for those, but everything is hypothetical. You construct the market scenario. People then are asked to choose between different programs or different type of goods, or how much are we willing to pay for these hypothetical goods. So it's quite good and nice because it's very flexible. You can ask any question that you're interested in. And you will also have control of the settings, so you know what people are answering to. You have created the market, so you know what people are choosing between. The problem is, of course, that everything is hypothetical. So there's a lot of evidence that there might be that people over-exaggerate how much they're willing to pay, or that there might be framing effects from how the scenario is provided, described, do you use specific words, do you use pictures, etc. So that may also influence respondents' answers. The other one, the review preference approach, is when you use market data. So for instance, you can use the property prices to extract information about how much people are willing to pay in an area with better air quality, or less noise, or better education, etc., etc. And this is usually what's preferred by most economists, especially those who don't work in the area of transport, environment, and health, because there's a lot of problem with review preference methods. You may not know exactly how people make decisions and what they take into account. You don't know the choice alternatives as you do in a state preference study. There might be a lot of correlations in the market data. So you would like to estimate, for instance, the willingness to pay to improve air quality and noise, but they may be so highly correlated in market data that you cannot identify the effects separately. And the same for a lot of transportation decisions. But what's really nice is, of course, it's real decisions. So people have made a decision in a market. So, and we then assume that people make decisions that are good for them. We know that people are not exaggerated with respect. But at the same time, as I indicated before, we assume that people make well-informed decisions, but also we assume that the analysts know how people make decisions. So as economists, we always complain that individuals are not as well-informed as they should be, but we assume that we can create models and analyze their behavior because we have the full knowledge. But it could be the case that people make well-informed decisions, but we may create models that don't really examine people's behavior. So they have their pros and cons, both approaches. And in this study, we use the stated preference approach, but I've also been involved in review preference on traffic safety. So just a brief introduction to what we're estimating in this paper. So we are focused on the value of statistical life, and also actually the value of statistical injury. But I will not go into any detail, but there is an underlying theoretical model behind the value of statistical life. So the value of statistical life is not the value of an identified individual or person per se. So when someone says that the value of life is, let's say, 3 million euros, doesn't mean that an individual has a worth of 3 million euros. The value is referring to the prevention of one statistical death in society. So it's all based on state dependent utility model, where we assume that people prefer to have a higher utility of consumption if they're alive than if they're dead. They have a higher marginal utility if they're alive than they're dead. And also we usually assume that we have weak financial risk aversion towards, financial risk aversion. So we can then derive the value of statistical life, and it's simply the ratio between the change in wealth and the change in risk. So it's nothing different than the marginal rate of substitution between wealth and risk. So here we have a difference curve, and it's simply the slope of the difference curve. And when we use this approach, we're usually in a situation where we have quite small risks. So it's maybe 1 in 10,000, up to, let's say, 1 in 1,000. And it's usually quite small risk changes. So we also assume, therefore, that the willingness to pay should be proportional to the change in risk. So usually we don't expect that people to be willing to pay twice as much for 2 apples as for 1 apple. So they're willing to pay, let's say, €1 for 1 apple, but let's say maybe €1.50 for 2 apples. But when we are looking at risk changes, we actually assume that the willingness to pay should be more or less proportional to risk change. Yes, please.
So the same apply to reductions in traffic time?
No, so this is, let's say, quite unique regarding risk reductions. Probably the value of travel time is that it's found to be quite dependent on which type of trips, which type of restriction that you have. So I don't work on the value of time, but I'm involved in these kind of discussions, conferences, but also I'm part of the Scientific Council for cost benefit analysis in Sweden in transport sector. And these are discussions that are always coming up. So also the value of time depends on if you're in, let's say, in the transportation mode, or if it's like between transportation modes. So transfer time is different from traveling time. So the value of time is I think this is complicated, but I think the value of time is even more challenging to address. So this is unique, this proportionality for reducing risks. So that was the theory behind the model, but just give you a little bit more maybe intuition about what we're estimating. So we have this scenario here, a city of 100,000 individuals. We assume that there are 5 deaths in the city a year on the roads. There's a safety policy that reduced the number of deaths from 5 to 2. And we assume that these individuals are willing to pay $150 a year for this risk reduction. So payment per year, risk reduction per year, so the same time frame. And we can then estimate the value of statistical life as simply how much they're willing to contribute to for this safety project. So that would be 15 million in total, 100,000 individuals paying 150 each, and we will prevent 3 deaths, so $5 million US dollars in this case for 1 prevented death. So before I show you the theoretical model, and this is providing intuition about how we estimate this value of statistical life, or what it means. Questions? Good. As I mentioned, in this study, we're not only looking at the VSL, but also what I call as a VSI, that is statistical injury. So we can simply transform the same model into non-fatal health risks. So here it refers as a value statistical case. So if we're focused on death risk, it's the value of statistical life, and if we focus on non-fatal risk, it's a value of statistical injury, or if it's illness, it would be value of statistical illness. And there's a lot of evidence in literature suggesting that people have difficulty understanding small probabilities. I think that's quite common knowledge also outside of the field of economics. Small numbers, small probabilities, difficult to understand. Here we're talking about changes in small probabilities. That makes it even harder. So what I talked about before, that the willingness to pay should be twice as high for a twice as large risk reduction. it's quite often found not to be the case. So quite often we find that people want to pay more for a larger risk reduction, but it's less than proportional to the change in risk. And I will come back to this later, why this is important. But there is a lot of evidence, as I mentioned on the first line there. And there's kind of this range of estimate that suggests there's some reliability of the evidence. But let's say the studies by Lisa Robinson and Jim Hammett, they've around between 2 and 14 million US dollars. There was a Swedish study that looked at a couple of years ago, and based on some selection criteria, so they kind of excluded studies that they felt were not of good quality, they still found a range of 1 to 11 million. I think for most individuals, that's quite of a large range. If you're working in this field on VSL, it's a fairly good range. And this shows that there's quite often a widespread of findings in the literature. So if you know the literature, you think, well, it's not that bad between 1 and 11 million. I can work with that. But I think for most of you here, I see on your faces that seems like a very imprecise estimate. But for us, when we work on it, it basically provides us with some kind of reasonable range where the value could be. But as you see, it's still, there's a lot of uncertainty about what the appropriate value is. So now when I presented the VSL and VSI, so this is a summary of the Scandinavian values that are currently used for policy purposes. And I've provided 2 different values for Sweden. OSEC 7.0 is the current values that are used, and OSEC 6.0 is the previous value that we used until quite recently. So you can see there for the Swedish estimate, you saw there's a big increase in the value. So all these values are local currencies. So Swedish value and Norwegian value quite easy. You simply divide by 10 and then you have the euros. And Danish is slightly different. But you get a picture where they are. So for Sweden, there was a, yes?
The first one is life. Or...
Yes, value statistical life. That's the first line. And the second line is value statistical injury, and there are different severity levels. So if you look at the VSL, we can see that the Danish and the Swedish value are quite close. The 34 million Danish krona is quite close to the 44 million Swedish krona. I think it's maybe slightly higher, maybe 45, 46, something like that. If we convert it. But there was a big increase from 6.0 to 7.0 for Sweden, based on evidence that Sweden was probably underestimating the value of safety. But there was also a big change regarding the value of non-fatal injuries in Sweden. So I've estimated here the death risk equivalent, which is simply the VSI divided by the VSL. So if the value of reducing a non-fatal accident or injury is the same as the VSL, the ratio will be equal to 1. Yes?
Do you know if the Norwegian numbers and Danish was stolen up an expert?
So the Danish and Norwegian values are also official values.
Yeah,
It's based on their kind of going through the evidence.
yeah.
Yes.
We had a lecture yesterday that stolen up with a professor in Norway gave.
Yeah.
He was actually telling us about the Danish and Norwegian numbers. And I think they're fairly new, and they were also a big increase from the old numbers, the same as you're seeing with your Swedish ones.
So these values are based on the review I did on literature a few months ago.
Okay.
So maybe that's Ståle provided new evidence because the Norwegian value provided here is a really old value that's kind of been, updated, taking into account income, etc. So maybe there's new evidence now, but this was based on what a review I did early, should be in December, it's a few months ago. So maybe a new one. And also as what you can see here, we're going to death risk equivalents. The Norwegian and the Danish relationship between reducing severe injury risk and the fatality risk are not that different. 0.20, 0.13, and the previous Swedish assessment was 0.17. But based on a new Swedish study that had used influence on the Swedish values, they revised them quite much. So now you have like 0.3 for severe injury. The problem with this comparison is that, you know, a death is a death, but reducing an injury risk would depend on, the preference for that would depend on duration, severity level, etc., etc. So it's much harder to compare the VSI values, but they're fairly similar, the description of these values. So one important objective of our study is to look at the new Swedish values regarding relationship between reducing injury risk and fatality risk. Are they robust or not, or should we maybe go back to what we had before? Yeah. So scoping sensitivity, as I mentioned before, why is that important? Well, in this study is important because here we're going to look at people's preference to reduce road risk, air traffic risk, and railway risk, and also sea traffic. And they have very different baseline risks. So in Sweden, the risk of dying on the road is today quite low. It's about, on average, 3 in 100,000. It's low internationally. Usually, I don't know what it is in Iceland. Maybe I should look that up. No one? I think I heard some stating a number.
What does that mean? 3 in 100,000?
Yeah, so
kilometers from
no, in people.
people.
So per year, yeah. So
3 injured in traffic.
no, three deaths
3 deaths
per 100,000. So it's about 300 in 10 million. Yeah. Yeah.
It was a lot higher, maybe 15 years ago. If we fixed the road to the airport and the southern highway. Doubled the lanes in each direction. The mortality rate is going rapidly down.
Yes, it's been going down in many countries, and I think the Nordic countries are in general quite good compared to many others. Yes.
I about the fluctuation. It's traditionally been rather low, but with the increase in tourism, it's spiked a little. But it spiked before the COVID. We have quite a fluctuation because of the we are actually not even we are just about 1/3 of a million.
Yeah. Yeah, if you have 2 then this year, that would be quite high compared to that. And of course, then it's really, because then you can have one car that's in an accident and all people in that car dies, and then that suggests that the risk has increased in Iceland that year, but that would just be fluctuation.
Very serious accident.
Yeah.
Even take it out of balance, take the average of 5 years.
Yeah. No, so this is what we usually do in this kind of stuff, because we know there's fluctuation, especially like small countries like not only Iceland, but Sweden is also a relatively small country. So these numbers are based on, let's say, the average over a few years. But then we have the problem of air traffic and railway risk. There's quite often 0 deaths in those transport modes. But even if there would be like maybe 1 death here, that would be 1 in 10 million in Sweden. And then if you're going to present the risk change, it needs to be smaller than the baseline risk, because you cannot reduce the risk more than the risk actually is. So therefore, when we compare this different type of transport mode, there's a high risk that our final estimate will be very dependent on the baseline risk, because the baseline risk will then have a big effect on the risk change. I will come back to this and illustrate why this can be a big problem. So there's been some evidence that studies looking at the air traffic risk have found very high values of how much people are willing to pay to reduce those risks than when they're converted into values to physical life. And that I mentioned before. And also together with Anna again and Mika Svensson, another health economist, we also show that when we compare estimates from different subsamples, we may find that there's no scope sensitivity. So if you change the risk in 1 by 10,000 or in 1 by 100,000, people are the same willing to pay. So if we then come back to how we estimated it, delta V, delta P, if we change the denominator but don't change the numerator, that will have a big effect on the final ratio estimate. So yeah, that's what I mentioned. So just to illustrate the effect that we'll have here, I'm not sure why the whole slide is not showing, but I think it's fine. We don't have much down there. So if you would have a population of 1 million in a city instead of the 100,000 and the same willingness to pay, the same change in risk, we will simply get that the VSL would be equal to 50 million instead of 5 million. This may seem like a strange example, like exaggerate, but this is actually what we got in our gene paper a few years ago. And this is then what we expect that we may get if we compare road safety with air traffic safety, if we use the baseline risk as they actually are. So we have made a modification here that we'll come back to later. Just maybe speed up. It's fine. So the aim here, of course, elicit individual preference for traffic safety. And we have a few more specific objectives to elicit VSL, VSI for road, railway, air traffic, and sea traffic. Useful to consider for policy purposes. So railway traffic may be of less interest for this group. Probably not even planned any railway lines, I think. No. Sea traffic should be of interest. There is at least some ferries, I know. We'd also then do both the discrete choice modeling and the continuation approach. And also we're going to look at this between sample scope sensitivity. So this study is part of a much bigger project where we look at a lot of different research questions, but I will show what we focus on here later in this study. So we have in total 7,500 in the total survey, 17 different subsamples. On the next slide, I will show exactly those subsamples that we focus on in this paper or manuscript. And we have done the standard stuff that you do in this kind of state of preference study. You test the study in focus group. The first thing we did was that we tested it on like colleagues, experts, and then we run it through pre-pilot, I would call it. So we had students at different universities who tested the survey online, and then we run a real pilot on, let's say, the general population. So similar to the one that we're going to use in the main study. So we did all the kind of pre-tests that we expect in a state of preference study. Data was collected last year. It took a little bit longer than we expected since the sample was quite large, but usually these kind of web panel studies, say in Sweden, if you have, let's say, 2,000 respondents, it would take a week or so to collect the data, but now it was a little bit more challenging. Scenario kept as identical as possible between subsamples. So basically just small twists to the different subsamples. So the basic format was the same, and then we changed whether it was a discrete choice experiment, or it was a choice modeling experiment, or there was a visual illustration to help the respondents, or was not a visual illustration. But basically everything was the same except for this kind of small twist to examine different research questions. And this is important, and you can also see the last line here, if I remember correctly. It simply says that we presented the baseline risk as aggregated risk for traffic. So we told them that the risk of dying in traffic in Sweden in a year is this number. It includes all different types of risks. And then we had this kind of cheap talk to explain that, assume that these risks are relevant to you. Because it was all in Swedish, but basically we told them that we didn't tell them that the risk wasn't correct, but we told those who knew that the risks were not correct that assume that these risks are accurate for you as well. Know what I mean? We didn't tell them these risks are not correct, but assume that they're correct. But there was a line so we could catch those who knew that there's so few risks, so few deaths in the air and on railway that this number doesn't make sense. And then we had this kind of cheap talk for that. And these are different subsamples I will present here. The discrete choice experiment. Can we change the size here so I can get the whole? When we try to do that, I will simply explain it. We have here, we used 4 different subsamples with discrete choice modeling. One where we have one attribute, I will show that later, that describes so which policy, so which transport mode with a policy address. Would it produce a risk on road, or would it produce a risk on in air, or would it produce the risk on the railway? Then there was another subsample where we only asked about reducing the risk of on road traffic, and there was another subsample where we asked only about the risk of reducing the sea traffic risk. And in the sea traffic risk, we explained to respondents this was not about. Seems right. It was not about the risk of dying on the sea. It was about the risk of dying in kind of on ferries and stuff like that. So not the private boat when you go fishing with your family or friends. It was about when you take like ferries, those type of boats. No,
Just one more time.
Yeah, and then we also had a scope test. So in the scope test, we simply divided the risk change by 2. So the risk reduction was just 50% of the one in the baseline, or let's say the default scenario. So the one with mode and road. So we had like our main scenario. So let's say that the risk change was 1 in 100. Then in the scope scenario, the risk change was 1 in 200. So with just 50% as large. And this was done to see whether there was this kind of sensitivity to the size of the risk. So the denominator, basically. So I will come back. You will see the results later. It will be clear. And for the continuation approach, there we only cover road risk, what we present here, and we also have the scope scenario there as well. Yeah, I hope I don't miss them. Yeah, it's fine. So standard structure for this kind of state of preference studies. So one more question related to traffic behavior, risk perception, experience, to get people thinking about the problem and get people kind of warm up to think about, so what's my preference for this? How do I feel about safety on the roads, etc. So quite standard. We then had a risk description, the scenario and visualization. So I do not show it here, but quite often we used to have grids, let's say 100,000 squares, and then we colorize those that illustrate the risk, just to show how small these risks are, so that people don't estimate or exaggerate the risk to themselves when they told that there is a risk of 10 in let's say 100,000. So just to show them like the magnitude of the risk. And as I mentioned before, here we vary between the different subsamples, but what I present here is when we use the best possible risk illustration that we can use. So we provide like the description step by step, explaining how this grid worked and what it meant that the risk changed, and then also when they show the question about the winners paid, they can go over the question and see how the risk changed, etc. So we did everything we can here to help the respondents understand the risk with a visual illustration. And then section 3, here we have the winners pay scenario. So either is continuation or is the choice questions. As I mentioned before, we had this cheap talk to get people on board about this baseline risk, especially that. provision point mechanisms, what happens if the scenario is not, or the policy is not implemented. And we also try to really stress that, if you pay this amount of money, you cannot use it for anything else. So we have this budget constraint reminder twice. And then background, demographics, socioeconomics, and follow-up question related to the survey itself. So if they felt it was realistic or not, the scenario, those type of questions. And we're actually going to use those later in the presentation. But this is a quite standard format for this type of stated preference exercises. Description, translated from Swedish. Try to provide as much information as we can so that all respondents have the same image in their head when they answer the question. At the same time, trying not to have too much text, because if there's too much text, I will not read it. So we really try to be precise, but not too precise. But this is the amount of text that I had to read. So explain that this is for 1 year, don't have to pay again. This is also quite important that the time dimension is clear there. What happens if it's not implemented, the money will be refunded. So they should kind of trust the scenario. So all this here, I would say, like state of the art standard, what you should do as we follow those advice. And then when we change from the different scenarios, so here, for instance, the measure may differ depending on whether they are intended to reduce the risk by road rate or air. So basically in the road safety scenario, that was the only thing that changed. Everything else was the same. All the other text was the same. So we really try to keep everything as identical as possible to make the subsample comparison. And there was description about the what would it mean to be injured? What would the effect? It would be for 6 months. This would be the effect. Prior to this, I've shown this kind of standard EQ 5D matrix with all different levels. So this was just a reminder about actually what's going to happen to them. Phase 8 choice situation is with choice experiment. And they should treat everyone as new. And as you see again here, this kind of budget reminder. So this is an example of the choice set that we asked. So this is just for my own Word files. So it looked a little bit better on the screen, but this is what kind of choices that to make. So they can choose between policy A, policy B. As you can see here, one of the attributes is transport mode and policy. So either it can reduce air or road risk. It could also be that there were also choices where both policy A and policy B would be about the same transport mode. And then the number of individuals who would die as a result of the policy, number of individuals who get serious injured as a result of the policy, and then the cost. And here's important to include non-owned policy as well, because we don't want to force individuals to make decisions that they don't really would make in real life. It could be that they are interested in reduced risk, but they think that the cost is too high. So then they should have the option to actually opt out here and say that I prefer the status quo. Pardon?
This is per year.
Yeah. So we had a big discussion where we should remind the respondents here that it costs you per year or not. We exclude that because we have one scenario where it's about a longer time period. So we wanted the choices to be as identical as possible between the different subsamples. So then we try to instead stress that in the scenario description itself, that now is per year, now it's per year over 10 years, to make as few changes as possible between them. But everything here is per year, and that's a really important question, because everything needs to be the same time dimension. Is the policy that we reduce the risk for 1 year, and this is cost per year. If we don't want the policy to continue, we need to pay again. That was also explained in the scenario. And here,
Sorry.
yes.
Were there no information on what policy would include? Would it be restriction to traffic? Would it be all sorts of provisions to make cars safer, or air traffic safer, or fewer simply going on the road?
No, so since preference may depend on which type of policy it can can be. Here we are kept it either just as a public safety policy, so the public decision maker will decide on something that will reduce the risk. So in that sense, it's quite abstract. We have one subsample that we haven't analyzed yet, where we ask about the private risk reduction. So you can rent a safety device that will reduce your risk. So we haven't looked at that data yet, but we will be interested in looking at what the effects are, because, and here we come into another dimension about altruism and provision of the good itself. When it's a private risk reduction, you may get one winner's pay. Is it a public? People may start thinking about other people's welfare, and they can reduce the risk of others, even if the public measure as well has been presented that this would only reduce your risk. So we're going to look at that, because there are all this interesting aspect about altruism, but also the provision. It could be more easy for respondents to accept the private risk reduction as believable. You're going to make a private decision. You can experience this reduced risk, and it can be perceived as clear. So I pay for this, I get this. But when it's a public measure, then people start thinking about, tax money being wasted, or that they may not really trust that the effect would be as large as they let's say, engineers estimate for the safety measures. So we may get different results there. But here, what I present here is about the public measure that was quite general. And one obvious reason for that is because we have this different type of risk. So we have railway, road, and air traffic. And it would be very hard to provide a quite more precise description of which type of measures should reduce different types of risks.
Is this what the reduction or the fatalities and the injuries, are they also including some other means, not because of the transportation itself, but the terrorism, or even criminals of being hurt by other passengers or something like that?
No, so here it's presented as, yeah, this is presented as traffic safety measures, and not like, let's say, the air traffic is about reducing the risk of accidents, not terrorist attacks.
Accidents.
Yes.
As such, not deliberate.
No. But then, of course, it could be that people still start thinking about those kind of things. So I don't think we have those kind of follow-up answers. We had answers. We had a question about how they perceive the survey difficult, etc., and it was realistic if they believed in the description. And then there was also open-ended question where they can answer why they didn't believe in it. But I don't think we have any issues like that. There's so many more issues about eliciting preference for safety that I don't think those are the main ones. The main one is people understanding and having trust in the government that they will actually provide this kind of risk reduction at this price. Other questions? So an interesting thing here is also that, let's say, if you see the same kind of study in healthcare, state preference, that they may leave out the none of the policies option, because there might be the case that if you ask a physician which kind of treatment they would choose between, and there are like different attributes they describe them, they may not have the choice to say, well, I will not do any of them. Those wouldn't make sense. They will make one decision, and they have to go ahead with something. But when we want to have monetary values to use for CBA, we always have to have the non-owned policy or the status quo alternative. That's one of the options. So 8 questions like this, and then level varies. So you get like 8 answers for each respondent. And this is then the CBM. So, and here we try to present it as similar as we can to the discrete choice experiment. And there's a lot of discussion among SP people about which one is best, CBM or discrete choice experiment. But as you can see, it's basically the same question. It's just that now it's just a yes or no question. So we have, let's say, dropped policy B, and you have reduced the CBM to a choice between one of the attributes and the financial cost. So you can simply see the discrete choice modeling as like an extension of the CBM question. So simple question, of course, it was the same scenario description before, but then the simple CBM question is, would you support the following policy? Number of few individuals who will die, and this is the cost, yes or no. So to analyze the data, we use standard models. So we have the utility specification. We can then derive the VSL as simply the minor rate substitution between wells and risk. So the ratio between the two coefficients. VSL is beta 1 divided by the marginal utility wealth, so beta 3, and for the VSI it would be simply the beta 2 in the numerator. But then we also have our model where we look at mode specific risk pay. So then we have interacted the risk reduction with the mode to see whether people have different preference for the different transport modes, and then we estimate. If I can do like that. Then we simply can estimate the mode specific VSL as this ratio where we take into account the interaction effect as well. So finally, the results. Took a while to get there. Yes, please.
I'm sorry, maybe I missed it. How is U measured?
So U is utility. So
Yes,
this.
but how do you, if you're using it as a dependent variable in a regression, you have like a.
No. So this is so we have discrete choice models here. So it's
Okay.
yes
So
or
you
no.
don't need it. Yeah,
Choose.
exactly.
Yeah.
Yes.
So in the CBM it's
Yeah,
just yes or no. In discrete choice, they can choose status quo or A or B.
Exactly.
Okay, so we have one where we simply look at the ratio between the attribute interest, and then we have one where we also interacted with the mode. So finally, the results. So in the first regression domain, we simply include the attribute of interest. And what we can see there is that, remember here that it was reduction in the risk. So we expect that injury and fatality should have a positive effect on people's choices. So the higher the risk reduction is, the more likely they are going to choose that alternative. So we expect a positive effect on injury and fatality. Cost should be negative because the more costly it is, everything else equal, they would prefer another alternative. And so we have those results there that we use as validity test. We expect people to choose things that are better for them, reducing risk and costing less. And what we then find here is also that seem to prefer policies that reduce road risk. We can then estimate, let's say, a generic VSL and VSI based on the main regression. So it's about 45 million VSL and about 3 million for the VSI. So if you remember the slide about the Scandinavian values, this is very close to the current official Swedish value for VSL, which is good for us, reliability test. You also remember maybe that was a large range, so we can expect a lot of different values. VSI is lower, but if we then look at the main model that we're interested here, that's a question? Nope. So the one that we're mainly interested in is when we interact the mode with the different risk types. So injury, rail, injury, air. So road is the reference group here. Then we can estimate most specific VSL and VSI. And as you can see here, we have the highest VSL for road, followed by rail, followed by air. And the same for the VSI. And regarding, for instance, here, a VSI for air is not even different from zero. But there's also, you can also see that there is not that strong evidence that, for instance, rail and road are different, the VSL. So the levels are different, but they also have the uncertainty there. But there is at least a direction that road may be higher than rail and air. And this is interesting because I would assume, based on the evidence and literature, that people's wins pay to reduce air traffic would be the highest one. Not only because this problem with that the risk reduction will be very small, so that will really inflate the values, the 50 million example before, but also because we had this kind of dread of dying in air. There's also the issue about controllability. There is evidence that people prefer risks that they can control. They dislike risk more that they don't have the sense of being able to control. So it's much worse being in an airplane than in a car, because in a car, even if you're a passenger, you can influence the situation by saying that I would not want to travel anymore, so you can step out. But in the plane, you're stuck there. Yes, please.
Yeah, no, to correct for the property that you are on the road or in the air or on the rail track are different for each individual. So you are spending much more time on the road. Could that be reflected in your estimates?
Excellent question. I will come back to that very soon. Now, because that was one concern we had, especially my colleague Jan-Erik, who's working at VTI in Sweden. It's very close to the transport authorities about the policy relevance about this, and whether different users have different preferences. Yeah. So that's the question. No, it's perfect bridge for me. So we actually tested that because we had a question about which type of transport mode they usually use. So we run regression with that, interacting and see, but we couldn't find at least any evidence that which type of transport mode that they frequently use has an effect on the preferences. That doesn't necessarily mean that that's the case, but we couldn't find any evidence that is the case. So that's good from that perspective. Maybe with a bigger sample, maybe we could be able to detect something, but at least in our sample, we couldn't find anything. The other question that I've talked about before is whether the baseline risks are unrealistic, and people felt that it's only about the road risk that it seems reasonable. The other risk is not relevant, so I choose road safety instead of air traffic and rail. So that may bias results. So as I mentioned, we have these follow-up questions. We're going to use that in our analysis. And we actually had it was unrealistic. And then we had a follow-up question if it was unrealistic, if it was because of the fact that the baseline risk for air traffic and railway traffic doesn't seem to be realistic to them. So we did that. So we excluded those who perceived this error not to be realistic and rerun the analysis. And if you have very good photographic memory, then you will see that these results are not that different from before. Basically the same. So road and rail have become slightly closer, but we have the same type of ranking between the risks. And air has increased also as well. So it's not that big of a difference. There's a slight difference. If this is going to be used for policy purposes, of course, the road administration or traffic transport administration may only look at the values, the mean value here, and not the uncertainty. So for them, it may matter, but for us, there's not that much of a difference. But still, these could be the values that we may recommend if we're going to use anything, because here we have taken into account that there are those who didn't find it realistic. So then we move to the next one. We only look at, we don't ask them about the different transport modes. Now it's only about road or only about sea traffic. So they only see one transport mode. So does that have an effect on the estimate? So as you can see, the coefficient are say they should be, so that's fine. And you can also see that the VSL and VSI are different from before, but not that very different, especially, regarding the VSL, for instance, on road, it's not something different from before. Where we do find a difference is that the VSI becomes smaller. So if we take this ratio between VSI and VSL, as I mentioned before, the decimal equivalent, before it was about 0.11, very much in line with previous Swedish official values and the Danish and Norwegian values. Whereas if you use the result from the CDM, is just 0.05. So what we find here is that the VSL gets larger with the CVM and the VSI becomes smaller, slightly smaller. And this is of course good and bad at the same time. So the result doesn't change that much at the same time for policy purposes. It has an effect. So using the discrete choice model approach or the CVM approach do have a slight effect on the values. And regarding sea traffic, what we do find here is that it's not that different from road traffic. So what the evidence suggests here is that people seem to have the same preference for sea safety, sea traffic safety as for road traffic safety. And if we then move over to the continuation approach, so I should soon be finished here. You can see here, so this has been, this is regression results that have been rescaled. So you see the VSL and VSI directly here. So the VSL becomes slightly higher, the VSI becomes considerably higher, I would say 3 times as high almost as in the discrete choice with only road. But again, there are like in the same, I wouldn't say range, but we have a Swedish word called havar, which is, you know, I'm not sure if that exists in Icelandic, something similar, but you know, it's in the same area, let's say, of estimates. But still, it has an effect. So using the discrete choice or the CVM also have a small effect on the results. And here we come to the between sample scope sensitivity. As you can see here, if we use the discrete choice model approach, if you remember the numbers, the VSL becomes twice as high. And also the VSL is about twice as high. And the risk reduction is 50%. It basically shows that the wind space is the same, even though the risk reduction is just 50%. So the ratio then becomes twice as large. When the wind space is the same, for a risk reduction, that's only 50%. This is a little bit, I think maybe I should have more slides on that. But it's coming back to the 50 and the 50 million example before. And we find the same for the CVM. And this is a bit frustrating, but it's an interesting research finding, because in the gene paper that I had with Arne and Mikael, as I mentioned before, we had a very small risk. We are looking at campylobacteriosis, which is extremely few cases of deaths per year. So it's in a million, 5 cases maximum per year in Sweden, in a population of 10 million. So it's extremely small. And we're hoping that this problem with the scope sensitivity was a result of a very small risk. But now we have a risk that's more reasonable, where there's a lot of evidence that it seems to work, these kind of studies. And we have the same scope problem here as well. And here we will dig a little bit deeper with the information we have about risk illustrations and experience, etc., etc. So we have a lot of information that we're going to see if we can help explain this problem. So the next step we're going to do, here what we have shown is just, let's say, average these estimate of preference for individuals. So we're estimating 1 beta coefficient for each model. So it's like the same preference for each individual. So the next step will be to examine preference heterogeneity. We've taken into account information that we have. Does income influence wins pay? Does age influence wins pay? Education, etc., etc. But then we also will go into the model where we look at the unobserved preference heterogeneity. So the things that we cannot control for, but the data can still suggest that there are preference heterogeneity in the model, like the mixed logic and the latent class models. Especially the latent class model, I think it's quite nice for this type of analysis, because you can quite often find that, say you may have, as an example, let's say 3 different type of classes. You have one group of individuals who behave as you expect. They're more likely to choose the policies with fewer deaths that cost less. You have another group who doesn't care at all about the cost. They only look at the risk reduction because they know it's hypothetical. And then you have a third group that just behave randomly. So the latent class model, I think, for this type of data is quite nice and useful. And we have a lot of information that we will dig deeper into. So about the standard analysis, suggests validity and reliability of estimate, was simply saying is that people behave as they should in a different choice set. So they prefer policies that reduce the risk and cost less. The values are in the range that we expect them to be. That's great. The VSI estimates differ from the current official estimates, but are more in line with previous Swedish estimate of the VSI in the transport sector, and also in line more with Norwegian and Danish estimates. Similar, slightly higher for CVM regarding the different approaches that we used. Most specific, so there's some weak evidence that road is higher than rail and higher than air traffic, but we don't find evidence that suggests that we should differentiate between the different transport modes. So this would be the first study that looked at this, where we have a control setting. And here we may have an indication that they may differ, but I wouldn't say that they're not enough evidence to suggest that we should have different values for different transport modes. Yeah, more research is needed. We always finish with that. If we can get more funds, that would be great. But then we have the same problem as we had before, the twin sample scope. So if you just look at one subsample, it looks very nice. Everything is in line with what we should expect. And then you do the critical between sample test, and you have this problem with the scope sensitivity that we also have for water and food safety in the other study. And we don't find that this discrete choice is better than the CVM. It's in the non-market valuation community, there's kind of sometimes fight between CVM people and discrete choice people. Here we cannot say that one is better than the other. And what's really nice, I think, about this is that instead of having people answering about, either reducing road risk or traffic or air traffic risk, they're forced to make choices between policies that take that address road risk or air traffic risk or railway risk. So this hopefully make them less inclined to kind of add things in their own head about air traffic. Oh, it's about terrorist attack. So then I'm willing to pay much more to reduce the risk of dying in the air because I stop thinking about terrorist attacks, etc. So we really think this is a good approach that discrete choice about to take into account this mode effects as an attribute. Disadvantage, of course, is that we have to, if we're going to have everything in the same scenario, we need to kind of merge all the traffic risk into one. And that, of course, becomes an issue about the realism. So we try to address it with a cheap talk, and maybe it worked based on the robustness test that we did or not, but always a question. Yeah, so it could be used for revision of current values, and this has been presented and reported to the Swedish transport authorities, and they are currently working on what to do with all the evidence that they have, because it's a big issue now, because they recently did some kind of calculations about what happened from this kind of 6.0 to the 7.0 transformation of VSL and VSI values, and it has a big effect on many policies, whether they are beneficial or not for Sweden. So there are big questions of policy relevance. So we find there's a lot of interesting research question, but it's very important also for policy purposes. Yes, please.
So how important would it be for Iceland to have estimates for the Icelandic population?
I would say quite important, because the thing is that in many cases we use benefit transfers. So let's say a country or a region don't have any values. So they take values from another country. Take into account differences. Quite often, let's say the wealth, especially if you transfer values from the US to, let's say, Cameroon, you cannot just take the US values and use it Cameroon. You need to take into account their wealth differences. The issue is that we don't know how good those benefit transfers are. There's a lot of evidence that benefit transfer area can be quite large. I think I would say recent, but I think it's 10 years ago now that there was a Gene paper on benefit transfer, and I think the median transfer error was about 30 or 40%. The mean was much higher. So if we do benefit transfers, it may work, it may not work. And the thing is that original values are always better than benefit transfer because they don't have an error. Benefit transfer always have at best a 0 error, but usually there is an error. So of course, at least doing some type of research, examining whether transfer benefit works or not. And to do that, you need to know what are the preference for the Icelandic population. Railway, maybe you can skip that, but road and air, I think, would be important in sea traffic as well. But road that's where we have most of the cases that we may also invest most of the money, especially regarding reducing accident risk. I think air traffic risk maybe be other risks that we are more concerned about there, where we invest a lot of measuring in safety measures regarding reducing risk in air traffic. Maybe not be that much about accident, but other type of risks. But yeah, I would say it's important. And like in France has used benefit transfer for a long time, and I think it's only recently, the last 2 or 3 years, there's been some French studies of what the VHL should be in France, and it's been one done on wage risk differentials or the job market, and another state preference study, and the values that they got differ very much from the recommendation that was based on some kind of European average before.
Unrelated question, completely unrelated. Can you tell us about kind of the laws or regulations around using CPA for policy analysis in Sweden? Because we don't have that kind of regulation in Iceland.
It's
There's nothing that forces the government or towns or anything to address the policy in a methodical way.
No, so it's actually in law. It's regulated in law that I don't remember all of the different things that should be taken into account when transport investment or transport policies are implemented. But to do some type of cost benefit analysis is one of those things that you have to do when you have projects in Sweden. That's also why we have, and that's been around the 70s.
Yeah. So I will tell you a little bit about how it's done in Iceland. I think the road authorities, they are at the forefront of using CPA. I think they do it with all or most of their projects, but no other sector in the government uses it. So we're also fighting for it to be used in the environmental sector. So we're very curious to hear about laws in other countries.
Yeah, so Sweden, I know that also the Swedish EPA, they have their CBA manual. I don't know to what extent it's also in the legislation that they have to do it for all the projects. Like in the healthcare sector, don't use CBA, especially because there's kind of an aversion to using monetary benefit measures. It's more common. It's what's used is cost effectiveness analysis when they look at the economic evaluation, or when they conduct economic evaluation of policies. In France, there's also legislation that you should conduct CBA, and especially for like bigger projects, there should also be this kind of pre-screening and ex-post valuation, all that. So it's gaining ground a lot in many countries, the use of CBA in different sectors, but it's still, I would say, the transport sector is at the forefront. And I think that it's quite easy because it's so much easier to accept it for transport sector, because it's a lot of, it's like financial costs, material costs. Many of the benefits are, not that related to emotional factors like health or the environment. We have so much more like emotional connection to the environment, cultural aspects, etc., and of course the health. Whereas transport is like building roads or railways, and yes, traffic safety, it's one, let's say, health aspect, but it's also more, let's say, one that's in a sense voluntary. You can decide how to travel more than maybe than being exposed to cancer or some other negative health effects. So it's still like, I would say, the transport sector
in other countries as well that's using more. Yes.
The value of injury numbers, because they differ a lot from your findings to the official Swedish numbers, and they increased a lot between A6 and 7.
Yeah.
Do you tell us what the basis for that policy change was? Is it, I mean, are the authorities trying to shift focus onto maybe unprotected pedestrians or stuff like that in traffic injuries? Or is it just, why not?
No, I would. So based on my, so it has a big effect, this revision, because now there's so few deaths that it's really, what the benefits are is reducing injury risk. So it's huge political dimensions. But I don't think, from my understanding of what I heard in discussion and following, etc., been in discussion, it hasn't been a political discussion that should be increased. The earlier death risk equivalent was based on some US evidence from, I think, from the 80s or something like that. It was about time to look at, you know, the numbers, if they were correct. So there was a big Swedish study conducted by some health economists in Sweden, where they come up with evidence of that suggested that the revision should be done in line with this. I'm not convinced that much. I'm not convinced that what they did is 100% correct. But that's another question. And what they didn't do in this study, they didn't estimate the VSL. They only looked at non-factor risk. So they used a chain approach suggested by the people in Newcastle some years ago, where you estimate the wins paid for this. A certain health effect. So how much, if you get ill, how much are you willing to pay to get back to normal health? And then they convert it into VSI by asking people about their risk preference, so probability equivalence. They go the other way around. But it wasn't a political decision, it was purely based on the new evidence in that study. But it has a big impact on, as I mentioned before, about the evaluation of different policies.
So basically, it's because the policies, I mean, because you have this zero death policy in Sweden for
Vision Zero, yes.
Vision Zero.
Yeah.
Then you basically need to up these numbers to push for the final numbers to go down.
No, so I would say that so the Vision Zero, you have different groups of people who are Vision Zero in Sweden. There are those who think that this is an actual goal, having zero deaths. But the Vision Zero is really about the vision. There's still numbers. You know, even when the vision was set up, there was still like a numeric goal. But this is a number that I think we reached that now. It was something about 270 or something like that. Deaths. So that's not zero deaths. Now we reach that. So. But if you have new policies that reduce the risk of death and injury, you will not have many fewer deaths, because you may have reached the point that there will still be deaths. So from a benefit perspective, yes, it's better if the VSI increase than the VSL. But as I said before, that's not from the information that they have. That wasn't the decision. This is based on economists' recommendation. These are guys. So it's not politicians that come up with it. This is based on, say, the best empirical evidence. So as I mentioned before, I'm part of that group, and we all had this discussion about, you know, now we're talking about the value of time, what we should do about that, and how we should treat transit in Sweden. If it's a transit through Sweden, or if it's like something that starts in Sweden, goes out, or something that goes out and comes into Sweden, those kind of things. So, and this is based on the research evidence and not about what's kind of the political dimension of the question.
Henrik, I think we reached the 10 minutes, so it's for comment. Yeah, we'll do the conference next month.
Yes, yeah, thank you very much for having me. I was coming to Iceland for the International Choice Model Conference next week, so that's why I reached out. Also give a talk. So thank you very much for coming, and sorry for using more of your time than I was supposed to. Thank you very much for your question. I'm happy to stick around and answer any questions.
If you take the chance to continue, I think some of them have been followers there.
Yeah. No, I'm happy to do that. Yes.
But I think it went well. I mean, I was hoping for more people to show up, apart from that.
No, but I totally understand. No, it's no, I think it was good. I didn't expect many more. Just when you said that there would be